All right, so this is chapter 11-5, volumes of pyramids and cones. I like the learning objective because I would find the volume of pyramids and cones. The volume of a pyramid is 1/3 the area of the base times the height. And it's the perpendicular height, the altitude height, not the slant. And that follows true for oblique pyramids. Has the same formula, but look, the height is from the peak to whatever point perpendicular to the peak. All right, let's apply this to this problem here. A sports arena shaped like a pyramid has a base area of 300,000 square feet and a height of 321 feet. What is the approximate volume? They've already calculated the base area for us, so please don't do that again. So the volume is 1/3 times 300,000 times 321. So when you crunch these numbers into your calculator, you get 32,100,000 cubic feet. All right, so the volume of a cone is the same as the volume of a pyramid. It's 1/3 the base area times the height. But fortunately, the base area is always the same for a cone. It's always the area of a circle. So we can say it's 1/3 pi r squared times h. And remember, that's the same for an oblique cylinder. The height is the distance from the very top perpendicular to the base. So as long as you know that height, you can find the volume of an oblique. So let's look at this question here. The height and radius of a child's TP are half those of the TP in problem 3. So the height was 12 in the previous problem, so it's 6 here, and it was feet. Yeah. And the radius was 14 in the previous problem, so it's 7 here for our problem. All right, so we want to find the volume of the child's TP to the nearest cubic foot. So we're going to take the formula, 1/3 pi r squared h, and we're going to plug in 6 for h and 7 for r. Pi 7 squared times 6. And then to the nearest cubic foot, so we're going to chug that into our calculator, which is quick and easy. So we go 1/3, so 1 divided by 3, times pi, times 7 squared, times 6, 307.876, and it says nearest cubic foot, so that would be 308 cubic feet. It says, what is the relationship between the volume of the original TP and the child's TP? Well, if I were to go the original TP with all the dimensions doubled, then we would go 1/3 times pi times 14 squared times 12. So if I look, 2,463 compared to 308. I'm just going to divide it by 308. So you can see that it is 8 times the volume. Of the child TV. Okay, we're going to go back to problem 2. The volume of a square pyramid with base edges, so I always draw the picture. With base edges 24 meters and slant height 13 meters. What is the volume? So we have a little dilemma because we don't know the altitude of our triangle. So anytime you're given the slant height, we are going to use that. If the whole side is 24, I'm just looking at this little triangle here where I got 13 for my hypotenuse and 12 for my leg, and I want to find the altitude, which is that dimension there. So I'm going to go h squared plus 12 squared equals 13 squared. H squared is equal to 13 squared minus 12 squared. 169 minus 144. H squared is equal to 25, so H must be equal to 5. So now I know if I'm going to use my volume formula, area of the base times the height, I now know my height. So I need to calculate what my base is, area of my base. So you look here, I have a square. To find the area of the square, I would take 24 times 24. And that is 576. And then I chug all of these in my calculator. 576 times 5 equals times 1 divided by 3 equals 960. And that would be in cubic meters. All right, so problem number 4 is our oblique cone, and we're going to find the volume of it in terms of pi and round to the nearest cubic meter. So volume of a cone is this formula here, 1/3 pi r squared h. So we're going to fill in the components. All right, let's put in the important information. So the 1/3 is a number, pi is a number. Our radius is 6. We're going to square it, and our height is 12. If we walk this through step by step, 6 times 6 is 36, times 12. I know if I shuffle this around, I got 1/3 of 36 times 12, and then the pi is on the end. A third of 36 is 12. And 12 times 12 is 144. In terms of pi, and rounded to the nearest cubic meter. So let's pull up the calculator. Let's go 144 times pi. 452. And let's put our units so we cubic meters. Let's look at the reasoning part. How does the volume of an oblique cone compare to the volume of a right cone with the same diameter and height? Explain. So the volumes are the same. Since the capacity for both is equivalent, one is just more sideways than the other one, but the volumes are the same.